This is question number 4 and it's medium level. The reason for that is because there is substitution involved and it's not just a straightforward in taking a derivative of the given function. So this has to do with the fundamental theorem of calculus again, and it's about part 1. The question says find the derivative of the function. So recalling the fundamental theorem of calculus, we know that g at x is equal to integral going from 0 to x, and we've got a function et. By part 1, it says when we take the derivative of this function, which represents this integral, that is equal to the function that's within the integral with this x substituted. But here we've got this thing that's taking place. Another function is at the end, not just a simple variable x that goes in. So this will take a form of a chain rule. When you take a derivative of something with another function that's inside, then taking the derivative of this entire thing, then it becomes, we have to take the chain rule of this. We want to use substitution to solve this. So this will be substituted by a simpler variable and call it u. So here we can say let u be e to the power of 2t. Then when we take derivative of this, it's going to give us e to the power of 2t, and then taking derivative of this according to the exponential rule, then we've got 2 and dt. When we divide both sides by dt, we get du divided by dt, which is equal to 2, this can come to the front, e to the power of 2t. So now that this is all set up, let's go ahead and take the derivative of this. Taking derivative of this function would involve d with respect to dt, because that's the variable that's used here. And we have integral going from 0 to e to the power of 2t, and simply writing out the function that's inside the integral d at x. Now, because we are substituting by the variable u, then we will have u here, so it's no longer t anymore. So then this will have to change to u. So this will be d over du, integral 0 to u, and we've got ln, nothing changes, that's inside the integral dx. However, because we are supposed to integrate with respect to t, and this will be substituted back in once we have taken the derivative, then we have to have offset this by putting taking derivative of du with respect to dt, so that it becomes taking derivative with respect to dt. That follows this expression right here, the first part of the fundamental theorem of calculus. So we are left with ln and 4u plus 1. We still have this du over dt still lingering around. So now it is time to plug this back in, which is 2 e to the power of t. When we do that, we also have to plug back in the original e to the power of 2t that's in place of u. So we've got ln and 4 e to the power of 2t plus 1, and d over dt was 2 e to the power of 2t. This is the final answer of the derivative of the functions. Remember, when you have to take the derivative of this function where one side is another type of a function, then you want to use substitution, but remember to use the chain rule. You want to set aside variables for u and take derivative of du and divide both so that you've got du over dt, and then remembering to plug these original variables back in once you have finally calculated the derivative.